Hello everyone, welcome to SPSVERSITY. I'm here, your chemistry educator, and I hope you all doing very good. It's a lovely evening to start the class with, and please like our videos and subscribe the videos if you really like our videos. And we are all open to the suggestions which you're going to give. So today I'm here with the new topic which is called as kinetics. This particular topic deals with a lot of energy and the motion and the speed of the reactions. So um, when we go ahead over here, I want you to be energetic throughout the sessions. Okay, yeah, here we go. So the topic which we are taking today is a kinetics. What exactly is kinetics and what do you hear about it? When you hear it, what do you say about kinetics as? Let me switch on to the YouTube as well. So if anyone is watching, um, yeah, here we are. So whenever we say kinetics, that deals with the study of speed of any reaction. So whenever the reactions happen, even the reactions which happen around us, like the teacher is going to scold you, and say in the class teacher is going to scold you, you want to respond but you don't respond. It, it's like a very slow reaction. You want to respond but you don't respond. It takes a lot of time. But the same thing if which happens at home, like your mom is going to scold, even when she opens mouth you will get to know that she is going to scold, and you immediately say something back to her. So this is an immediate response. The same way the chemical reactions, based on their speed, how fast they happen, we have majorly three categories. One is a fast reaction, second one is a slow reaction, then the next one is a moderate reactions. Whenever we say fast reaction, these are the reactions which happen in a fraction of a second. Like in the laboratory, you take a salt solution which contains halide ions, and then you are going to mix it with the silver nitrate to solution. Add dilute nitric acid and silver nitrate. Immediately you get the white precipitate. The fraction you mix it, you get a white precipitate, right? So these are the reaction, and the burning of crackers. Once you put a fire to it, it immediately explodes. So all these are considered as fast reactions which really happen in a faster way. And then we have the second thing, which is called a slow reactions. This may take a lot of time and you can't sit and do this. Even if you are given with the titration, what you do, you turn on the knob, when the teacher passes nearby. If the teacher is nearby, then you put drop to drop and you stir everything. When the teacher moves and when she puts her back to you, what you do, you immediately turn the knob like the tap water, and you stop swirling and you hold your hand near your waist, right? That's how it happens. Even if the reaction takes place in 10 minutes, you have no patience to study or do those experiments in a proper manner. Then definitely the slow reactions, these are not your cup of tea. So these take place in a week, in a month, like rusting of iron, which needs the iron when it is exposed to air and the atmosphere. That's atmospheric air and the moisture. It takes a lot of time to get rusted, that brownish coating. So these are the slow reactions. And then we have the moderate reactions, which happen in a couple of hours, which we can sit and study. And then these are called as moderate reactions. And for example, hydrolysis of ester, all these are the examples. So in all these reactions, we come across a term which is called as a rate. If you have observed what is written on the sheet over here or on the page over here, it's the rate of the reactions. What exactly is a rate? How do you define rate as? Rate of a chemical reaction is how fast it moves, how fast it goes to the completion. Okay, so you can define it as change in the concentration of any of the reactant or the product per unit time. So there are reactions which are reversible and which are irreversible and which have the branched reactions. Like if A gives rise to B, you have this kind of reaction. Or better to take it as, I'm changing it. Yeah, reactants give rise to product. So this is a reaction which we are having. Now in this particular reaction, it's a unidirectional reaction. It's not reversible. So if you take with 100 molecules of R or 1 molar concentration of R, the concentration of the reactant decreases, because initially you will be having only the reactants. When the reaction proceeds, you will be having products which is going to be accumulated, and when the reaction completes, you are not left with any of the reactants, but you have all the molecules which got converted to products. If it is a reversible reaction, then the reactants give rise to product get converted back to the reactants, which we will see later. For time being, we'll consider the reactants give rise to product. In this particular reaction, so you start at a time t is equal to 0. Whatever the time you start, that's the time is equal to 0. Say you have 1 molar concentration of R, and you measure after 10 minutes. You put around to your entire campus in college, and you come back, and the 10 minutes are over. You're going to measure the reactant concentration once again. Now the reactant is being converted to product, so some of the concentration of the reactant has been gone down, isn't it? Now the initial concentration when you started the reaction and the final concentration when you did the experiment after 10 minutes, or the measure the concentration of 10 after 10 minutes, then the initial concentration minus the final concentration, or the other way, divided by in what time does this change happen. That's called as rate of the reaction. Change in the concentration of any of the reactant, it can be more than one. If it is A plus B, those are the reactants, then you can consider both the reactants. Change in the concentration of any one of the reactant, or all the reactants, or change in the concentration of the product. Even the concentration of the product is changing, it is increasing when the time changes, right? So divided by the time is called as rate of the reaction. Generally it is expressed, whenever we say concentration, we express it in terms of molarity. So mole per liter divided by, if it is unit time, you can take it as seconds. Some reactions may take the unit of per minute and per hour also, but if it is in the problem, then you have to convert according to the problem given and looking at the unit of time. Otherwise you can keep it in mole per liter per second, mole per liter per hour, mole per liter per minute. Okay, if it is a gaseous reactant, then the pressure changes during the reaction. In those cases, change in pressure over the time, that's atmosphere, is a unit of pressure, divided by time is a unit which you can consider. Okay, so if you are given with the reaction, wait a second. Okay, if you are given with the reaction, that's R gives rise to product, then you write rate is equal to change in concentration of R, I'll put D, divided by time, which is equal to change in concentration of product, because the rate of disappearance of R is getting disappeared, divided by time. But the concentration of the reactant goes down, so we put a minus sign, and the concentration of the product increases, so you put a positive sign. So for all the reactants, you can put a negative sign because their concentration is going to decrease with respect to time. And for all the products, you can put a plus sign because the concentration of the product increases with respect to time. Hope you get it. Now, if you have a general reaction, this is when the stoichiometric coefficients, or the number of moles or the molecules, is 1 and 1. If it is this way, I'm just writing a reaction AA plus BB gives rise to small cc plus DD. What are ABCD, capital ABCD? These are the reactant molecules. Small ABCD, these are the numbers to balance the reaction. Then you write rate as minus dA by dt, which is equal to minus, you should remember why it is minus, it is decreasing, which is equal to plus dc divided by dt, which is equal to plus dd divided by dt. Where do these numbers go? A, B, C, D. They come here. A, B, C comes over here, and D comes over here. Did you get all these numbers? They come down. This is called as rate. Now, what are the factors which affect the rate of the reaction? Definitely we know that rate is change in concentration. That's what we have to write. I'm writing it over here. So if you find these as important ones, you can take down when I explain. Rate is equal to change in concentration over time. So when the concentration changes, the rate of the reaction changes. So definitely the concentration is going to have some effect on the rate, and also the temperature. So when the temperature changes, the kinetic energy of the molecules change. So the rate changes. Surface area of the reactants. So larger is the surface area, there is more space available for the reactants to get accumulated on the surface, and they react. So the change in the surface area is going to affect the rate of the reaction. Then we have the radiations, the catalyst. We know that the catalyst is going to affect the rate of the reaction to a greater extent. Okay, then the pressure of the gas. Instead of concentration, you just have the pressure, which is going to affect the rate of the reaction. Okay, hope all these points are very clear. We are going to see them in detail. Then whenever we see the rate, we have two things here. One is the average reaction rate, the other one is the instantaneous reaction rate. What is average reaction rate? So you start the reaction, and so how do you draw the graph? Time over here, the concentration over here. Say we are starting with the reactants, the concentration of the reactant goes down with respect to time. Say this is a graph, and this is time in say seconds, 10, 20, 30, 40, 50, 60, like this it will go. Now say you measure the rate at a particular time. For example, let this be the concentration, say 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, like this, and 0 0.6. These are the concentrations. Now at 20 seconds, I'll write it over here. When the time was 20 seconds, the concentration was 0.3 molar. You measure the concentration again at time 30 seconds. This is 0.2 molar. Now rate is equal to change in concentration, that's 0.3 divided by 0.2, sorry, 0.3 minus 0.2 divided by, or final concentration or initial concentration, anything you can do over here, divided by change of time, that's 30 or 20 minus 30. You can do this. That's going to give you, you can put a positive and a negative sign later, depending on whether it is the reactant or the product. But generally when we take the just the way I'm explaining, where you have different concentration at different time intervals, so this is going to be 0.1 divided by 10. So this is the average reaction rate at a particular time, say 10 seconds or 10 minutes. What is the change in concentration? That's average reaction rate. Whenever you say instant, say you need the rate of the reaction at 40 seconds. What exactly is the concentration at time when it is 40 seconds? That is called as instantaneous. What is instantaneous? At that moment, at that instant. So the rate at a particular instant of time or at any given point of time, that's called as instantaneous rate, and it is given by generally rate is equal to minus d, I'm considering R divided by dt, which is equal to plus d product divided by dt, where R and the P stands for reactant and the product. Now so what do these this delta and this delta refer to? This is a bit bigger change because we are considering two different intervals, but this is a smaller because the small d, it's smaller because you're considering the rate at that particular instant. Okay, these are two examples, I mean two different reaction rates. So we have a question over here. uh, Consider the thermal decomposition of gaseous N2O5 to NO2 and O2 via the following equation. That's 2N2O5 on heating. That's going to give you 4NO2 plus O2. Now write the expression for the change. What is that? How do you solve this now? Just any expression you can give, but we'll take the average rate. Rate average is equal to change in concentration of the reactant. So minus delta, in terms of reactants we are writing N2O5 divided by delta T, which is equal to, there is only one reactant, then rest of them are the products. So the concentration of the product increases, NO2 divided by delta T, which is equal to plus delta O2 divided by delta T. This is how you write. If the concentration of the reactant decreases, the concentration of the products, they are going to increase. And now here what we have over here is, if they give you different timings in the concentration, you can directly apply them and get the rate. You can write R instantaneous as well, replace the D, divide by T. But one thing is missing over here. These numbers you have to put them down. 2 delta T, 4 delta T and 1. You need not mention it. So all the numbers which are there in the balanced chemical equation, they come down. Okay, we'll move on to the next question. So how do you answer this question? The rate of change in the concentration of the reactant of R in 2p plus q gives 2r plus 3s was reported. Calculate the change reaction rate as well as the change in concentration of PQS. First, let's write the reaction. So we have the reaction. How do you write the rate of the reaction? Rate is equal to, you can put any number. So delta P divided by 2 delta T, because 2 is there along with P, which is equal to delta Q change in concentration, which is equal to delta whenever it is the reactant, put minus, and if it is a product, put a positive sign. Now the question is, calculate the reaction rate. How do you calculate the reaction rate? Rate of change in concentration they have given, that's minus, or just I'll put dr by dt, that's better. They have given dr by dt is equal to 1.0 mole per liter per second. That's the rate. But because they have given delta R divided by delta T, change in the concentration, what we have? We have to find out the change in the concentration of P. Delta P divided by delta T. You can put the other delta also, which is equal to change in concentration, because the two to get cancelled and you are left with the same value, 1.0 mole per liter per second. If it is delta Q, what is the relationship you have? Delta Q is equal to, divided by dt is equal to, if you, how do you find it out? Half of delta R divided by delta T, which is equal to 0.5. Half of this is mole per liter per second, and minus delta S divided by delta T, change, make everything the same way. Then you are going to get, there was 3 over here, 3 comes to the denominator, and you, here there was, wait a minute, delta S divided by delta T is equal to delta R into 2 delta T. When you rearrange it, it is what you are going to get, Okay. Times 1, which is equal to 1.5 mole per liter per second. So what rate of the reaction? These are different rate of the reaction. What is the rate of the reaction? It is half. That's 0.5 mole per liter per second. They have given the change in the concentration. The rate of the reaction will be, you have to divide it by 2. So you're going to get 0.5 mole per liter per second. Then we have the next topic, which is called as rate law. What exactly is rate law? So whenever you do any reaction, whatever you get the experiment, whatever you get in the laboratory, the results which you are going to get in the laboratory, that might be different from whatever you have written in a balanced chemical equation. For example, 2R gives rise to 4P. If this is a the balanced reaction, two reactant molecules react together, four number of products. Now, if you do it in the laboratory, whatever the reaction you have written just now, this is a theoretical one. You're going to see the number of atoms on the reactant side, you are not going to see the number of atoms on the product side, then you balance. This is in the on the paper sheet, where you are going to count the number of atoms on either side of the reaction. Now, if it is done in the laboratory, it may not be the same. 2R gives rise to 4P. This need not be the case. It can be 1R gives rise to 4P. If that is the case, then if it is, since it is done in the laboratory, we are going to consider the same thing for the rate law expression. So the expression, the definition of rate law is the expression of any rate of the reactions in terms of the concentration of the reactant is called as rate law. That means for any chemical reaction, A plus BB gives rise to product. If this is a reaction where A and B, these are the ones which are obtained in the balanced equation. And when you do it in the experiment, this may be different. Then you write rate is directly proportional to the concentration of the reactant. You know this, right? Always the increase in the concentration of the reactant increases the reaction rate. Now, these numbers become the powers x and y, where x and y is the experimentally determined one, a and b are the theoretical one, where you use those numbers for balancing the equation, and x and y may or may not be equal to a and b. So whenever we say rate of the reaction, rate is equal to k times a to the power x, b to the power y. So we say rate is equal to, always rate is proportional to the concentration of the reactant, or rate is equal to k into a power x, b power y, where x and y may or may not be equal to a and b. And also this, how do we define the rate constant, which we added over here to remove the proportionality symbol? When this is equal to 1, this is equal to 1, then k becomes equal to rate. So the rate constant of any reaction is the rate of the reaction when the concentration of the reactants is unity in the rate law expression. Okay. And this rate constant K, this depends upon number of factors. What are those? One is, greater is the value of rate constant, faster is the reaction. It is going towards completion. So higher the value of rate constant, you can say that the reaction is going in a speed manner. Each reaction, so if you take any particular reaction, that's going to have a rate constant at a particular temperature. So for any particular reaction, there may be more than one rates at different temperatures. So value of so if a particular reaction is happening at a particular temperature, if you change the temperature, the rate of the reaction is also going to change. And the rate constant doesn't depend upon the concentration of the reactant. You know why? Rate is equal to change in concentration of over change in time, which is equal to K. That's how you define K as. That's a rate constant. It's a change in concentration divided by change of time. So it doesn't depend on the concentration of the reactant. It depends on the change in concentration. So if it is a forward reaction and the backward reaction combined together to give a reversible reaction, then how do you define rate as? So in this case, I'm writing it over here. So this is a reversible reaction. In this case, rate is equal to half of dNO2 divided by dt. The decrease in the concentration of NO2 divided by 2, because there is 2 over here, which is equal to K1. So we'll consider the forward reaction. That's K1 into NO2 to the power 2 minus K2 into N2O for power 1. So if you have reactants is in equilibrium with the product, then you write rate is equal to, say the rate constant for this particular reaction, this will be K1 and K2, then K1 into the concentration of the reactant minus K2 into the concentration of the product. This is how you put the rate in case of reversible reaction. Then we come to the next topic, which is called as a molecularity of the reaction. Whenever you say molecularity, so for any reaction, the reactant molecules collide and with the sufficient energy, of course, and they form the products. The molecularity is the number of molecules which are going to collide in a reaction. Generally, whenever you say a chemical reaction, the probability of molecules colliding more than thrice or four times is difficult. So if one reactant molecule is involved, that is called as unimolecular. If two reactant molecules are involved, that is called as bimolecular. If three reactant molecules are going to be involved in any chemical reaction, they are going to collide, then it is called as termolecular reactions. Okay, so molecularity applies for only the uh, element reactions. In case of complex reactions, we don't mention the molecularity. It should be for the reactant in the only one step reaction, the element in the sense one step reaction. For that we mention the molecularity. Okay, then we come to the order of the reactions. When we have the reactants give rise to product, we write rate is equal to K into concentration of the reactant to some power. Or if there are two reactants involved, A power some A concentration of first reactant, that's A power something into concentration of B power something. Now this is in case of rate law expression. If those powers are added, x plus y, that's called as order. So whenever you see order of any reaction, it is the sum of x plus y powers of what are, whose powers they are, the concentration of the reactants. From where do you get them? From the rate law expression. So the sum of the powers of concentration terms found in the rate law expression is called as order of the reaction. So if you consider the reaction here, A rate is directly proportional to A to the power x, B to the power y, and which is equal to K into A to the power x into B to the power y. Here if you add these powers, this becomes the order of that particular reaction. Now we have some differences between the molecularity and the order of any reaction. So whenever you say the molecularity refers to the number of reactant molecules which undergo the collision. So if you have any reaction, how many reactant molecules are going to collide? That's called as molecularity. Whereas the order, it's a sum of parts of the concentration terms in the rate law expression. So here we define the terms molecularity and the order as the first difference. The second one, molecularity, whenever you say molecularity, it is a theoretical concept where you take the balanced reaction and say these many reactant molecules are going to collide. And if it is order, it is a practical one which is obtained from the laboratory after doing the experiments. Then the molecularity can have the whole number values, because half of the molecule reacting, zero molecule reacting, negative molecule reacting, all these cases are not possible. So whenever you say the molecularity, it is a theoretical concept. Whenever you say the order, it is a experimentally determined quantity. And the molecularity cannot be zero. Why? Because if the reactant molecules which are going to take part in the reaction, if they are zero, the reaction will not happen ever. So that's why the molecularity of the reaction cannot be zero, whereas the order can be zero, it can be negative, it can be positive, it can be whole number, it can be a fraction. Okay, then the molecularity doesn't give you, only it is going to say how many reactant molecules are colliding in that particular reaction. Other than that, it won't give you any other information about how the reaction is going to proceed. Whereas in case of order, um, the the different steps are mentioned over here, and you will get to know what exactly is the order of the reaction. That means how fast, how you, if the particular reaction has three different steps, for example, if it is a complicated reaction or the complex reaction, the reaction is going to happen in three steps. In those three steps, which is the slowest step, that steps number of reactant molecules or the power, that's taken as order. For example, one more thing, whenever you say the molecularity, it cannot be zero, that you have to remember, but order can be anything, fractional value and also the negative value. Okay, then we define the next one. We have a question over here. So I guess how do you know how to write the order? So if you have a reaction, particular reaction, so 1A plus 2B gives rise to product. Then you write rate is equal to K into concentration of A to the power 1, concentration of B to the power 2. This is how you put the order as. Say this is the experimentally determined one, not the theoretical one. Then where this 1 and 2 are the practically determined one. Now we have a question. Okay, I didn't mention order. Order is equal to this, the sum of these two, 1 plus 2, which is equal to 3. So it is a third order reaction. We have a question over here. The rate of oxidation of bromide ions by bromate in an acidic solution, aqueous solution, has this one. So what happens to the rate? I'm sorry. So how do you write the rate equation for this, or rate law expression? Rate is equal to K into, this is a rate law expression for this equation. Now the question is, if BrO3 is doubled, I'll use the different ink so that you'll be able to identify when you solve the problem. The first one, BrO3 minus is doubled. If the concentration of BrO3 is doubled, where the rate is equal to K into, all other remain as 1 only, because their concentration is not going to change. Instead of BrO3, you have to put 2, because its concentration is doubled, right? So you have to put 2 times, now, which is equal to K into 1 into 2 to the power 2, sorry, its concentration is, I'm sorry, concentration is doubled. You should not change this one over here on the top, only you have to change this to times 1 to the power 5, because all these concentrations will remain as they are. So this becomes is equal to 2K. So the rate is going to double over here. Can you see that? The rate doubles. So when BrO3 concentration is double, the rate is going to double. Now, the next question. If the pH is increased by 1 unit, we know that, I'll write the option B here, pH is equal to minus log H plus. So whenever the pH changes, the pH difference, if it is 1, then the concentration H plus change will be 10 factors. There will be 10 times change. This is equal to, pH is equal to minus log base to the 10 H plus. Now, if the pH is increased by 1, when the pH is increased by 1, what happened to the concentration? Or if the pH changes by 1, the H plus concentration changes by 10 times. So the rate is equal to K into, in the place of H plus, what you have to write? There is a 10%, 10 change. Do you get that? I'll repeat again. Now, pH is increased by 1 unit. When the pH changes by 1 unit, the H plus concentration changes by 10 times. So what does that mean? If the concentration of 10 plus H plus changes by 10 times, then the rate is equal to K into 10 H plus 6 times. Rest remain the same. So the rate changes by 10 to the power 6 factor. We have the next one. That's equal to C. The solution is diluted to twice its volume with the pH held constant. So the concentration of H plus doesn't change, but the concentration of the solution is diluted to twice. So what happens to the concentration of BrO3 minus and 5Br minus? What happens to them? When the solution is diluted to twice, what do you expect? What change you expect? You can put your comments in the comment section down over here so that I can go through it. Okay. Then the solution is diluted twice. The new rate is equal to K into the pH is kept constant, so that doesn't change. But according to the equation I'm doing, not according to the rate law expression, because I am going to change this later. So the rate is equal to, this remains the same, K into H plus concentration remains the same, but since it's diluted twice, this becomes half BrO3 minus power 1 and half Br minus to the power 5. If this particular rate law expression was not given, then these would have been the answers. Do you get that? But they have given the rate law expression. So all of this change, I want you to remember this. Sometimes what we do is we just ignore this rate law expression, but we have to take into consideration of rate law expression. Then if BrO3 is doubled, according to this, rate is equal to K into Br minus BrO3. This is experimentally determined one, H plus square. So the question A, if the concentration of BrO3 is doubled, so K, this remains the same, 1, this remains 2 BrO3 minus into, again it's 1. So because their concentration doesn't change, so it becomes 2K. Previously it was just K, now it is 2K, the rate doubles. The second one, the pH is increased by 1 unit. What do you think? So the rate is equal to K into Br minus BrO3 minus, the concentration of H plus is going to decrease by, if the pH is increased, then you have the concentration of the concentration of H plus is going to decrease. That means it's 1 over 100 times. The concentration decreases. Oh, sorry, the rate decreases. Third one, if the solution is diluted to twice the volume. Since rate is not affected by the pH over here, so you have to take into consideration of Br minus and the BrO3 minus only, because they have told the concentration of H plus is kept constant. So the rate doesn't depend on the concentration. So this becomes half Br minus, half BrO3 minus. So what you have? 1 by 4K. Rate decreases by 1 by 4th time. Hope you got it now. Then we have the zero order reactions. Whenever you say zero order reaction, so how do you put any reaction as? To keep them simple, I'll take R gives rise to P. The rate is equal to K into the concentration of reactant to some power. Whatever the power you are going to give here, that becomes the order. If it is zero order, put 0. Or rate is equal to K into anything to the power 0 is equal to 1. So zeroth order reaction is the one whose rate is independent on the concentration. So R per 0, the reactant concentration per 0. So rate is independent on the concentration of the reactant, and rate is equal to K. That's how you write the rate law. Almost all the reactions which happen on the surface of any metal, they are called as zero order reaction. Now, if it is 2N2O on the surface of platinum gives nitrogen and the oxygen, then how do you put rate as? Rate is equal to half. This is the how you rate change in concentration over time, which is equal to the rate is equal to K into N2O to the power 0, which is equal to K. This is how you get the graph as change in concentration of the reactant. This refers to the reactant because the reactant is the concentration is high in the beginning, then it goes to 0, whereas the product concentration is 0 at the beginning and it ends up higher when the reaction is happening. Now, how do you write the rate law expression? I'm writing it over here. For the reaction, R gives rise to P. Rate is equal to K into reactant concentration put the power 0 because it's a zero order reaction. Now, after this, rate is nothing but dR divided by dt. This we all know. Into K. You bring this here, bring this negative sign to the side. So that becomes equal to dr, which is equal to minus k dt. You integrate to get the terms. Integration of dr is equal to r, which is equal to minus kt plus integration constant I. To get the value of I, what you are supposed to do, I'm changing the ink so that you don't get bored. What is that you are going to get? So when time t is equal to 0, the concentration R becomes equal to initial concentration. When you started this, the R is a concentration is at time t, and R naught is a concentration at time t is equal to 0. So put those values. R is equal to minus KT. If you put that t is equal to 0, you get R naught is equal to 0 plus I. Now, in the place of I, what you have to put? R naught. You rearrange this expression. Then you get KT is equal to R naught minus R, or K is equal to R naught minus R divided by T. And you can draw a graph for this also. Y is equal to mx plus c for this expression. I'm changing the ink so that you distinguish between them. Yeah. See, if you draw a graph of reactant concentration versus time, so you get it's a negative. So you start with the initial concentration. This becomes equal to R naught, and the slope of the line is nothing but K. Hope you get it. This is how you get the rate law expression for the first zero order reaction. What is the unit for rate constant? How do you get that in case of zero order? We have rate is equal to concentration over time, which is equal to K into change in concentration to the power 0, or concentration is mole per liter, the time is second per second, which is equal to K, because its concentration is equal to 0, which is equal to 1. So the unit of rate constant in the zero order is it is the same as that of the uh, rate of the reaction in case of zero order, which is mole per liter per second. Hope you get it. Now we'll move on to the MCQ section. Which of the following statement is not correct about the order of the reaction? If you are watching this video, you can put your answers down over here so that I'm going to see them and reply. Or yeah, so here we go. The order of the reaction can be a fractional number. Is that so? Yes, it can be a fraction. And the second one, order of the reaction is experimentally determined quantity. Always whenever you say the order, you get it from the experiment. So that is also true. They see the question first. What they have asked? They have asked which of these is not correct. Make sure that you read it correct. Is not correct. You have to go through. Okay, the order of the reaction is always equal to the sum of stoichiometric coefficients of the reactants in the balanced chemical equation. It is not in the balanced chemical equation, it is in the rate law expression, which is found from the experimental data. So the one which is not correct is this one. The order of the reaction is the sum of powers of molar concentration of the reactants in the rate law expression. This is also right. The one which is not right is option C. The next question we have, which of the following statement is correct? The rate of the reaction decreases with passage of time as the concentration of the reactant decreases. The rate of the reaction is same at any time during the reaction. Rate of the reaction is independent of the temperature change. Rate of the reaction decreases with the increase in the concentration of the reactant. What do you think is the right answer? Now, the right answer would be the rate of the reaction decreases with the passage of time. Rate is directly proportional to concentration. So if the rate has to decrease, the concentration of the reactant has to decrease. Both decrease at a particular instant of time. So when the reaction proceeds, so the A can be the correct. Okay, again you see which is correct, because in the previous question it was not correct. Now the second thing, the rate of the reaction is same at any time during the reaction. It need not be right, because the rate of the reaction can change. It depends on the temperature also. The rate of the reaction is excuse me, is independent of the temperature change. No, it depends on the temperature. So the rate of the reaction always depends on the temperature, as it depends on the kinetic energy and the collisions. The rate of the reaction decreases with the increase in the concentration of the reactant. This is definitely not true. So the one which is correct is option A. Which of the following expression is correct for the rate of the reaction given below? You have to just express it in terms of change in concentration over time. So how do you express the rate? As they have given only two species, that's Br minus and the H plus. So change in rate is equal to the change in the concentration of Br minus, that's a reactant. That's why phi comes to the denominator, delta T, which is equal to, again they have given it terms of H plus, so it's a reactant, delta H plus divided by that 6 comes to the denominator, 6 delta T. The negative signs get cancelled, this phi goes to the denominator, so you get delta Br by delta T, which is equal to phi goes to the numerator, phi H plus divided by 6 delta T. Just see where phi and 6 are. It's in option C. Whenever you see this kind of questions, if the rate law expression is not given and you have to find out the rate of the reaction, then you see the numbers. There are numbers. If the numbers are not there, see 5 and 6 are there. In which option 5 and 6 are not there, you eliminate them and you can select the right answer after that. You have this one. Rate law of the reaction A plus 2B gives rise to C is found to be rate is equal to K into concentration of A into B. So they have given you the rate law expression. What is that? Rate is equal to K into AB. A concentration of B is doubled. Keeping the concentration of A constant, the value of rate of constant will be. Okay, so the concentration of A is kept constant. So if you change, you can't change the concentration. So rate is equal to K into, there is one only, and the concentration of B is doubled. The concentration of this is doubled. So K into 2. The rate of the reaction doubles. So it is doubled. If it was according to this, then rate would have been, rate is equal to, how do you write for this? Rate is equal to K into A to the power 1 to B to the, B to the power 2. If you double the concentration of this, now it is 2 square, which is equal to 4k. But this is not the answer because they have given the rate. This is a theoretical one, which is the equation, and the one which they have given down is a practical one. Hope you get it. We have two questions over here. The rate of the reaction that does not involve gases is not dependent on. So if there is no gas reactant, gaseous reactant or the product in any reaction, then the rate of the reaction doesn't depend on. So if the gaseous reactant or the product is not there, that means there should be a solid and the liquid reactant or the product. Both of them, for solids you measure the mass, for liquids you measure the concentration, and in both the cases, with the addition of the catalyst, rate of the reaction increases, and with the temperature the rate of the reaction is going to increase. But since solids and the liquids both are less compressible by the application of pressure, they do not depend on the pressure. That would be the right answer. The rate at which the substance reacts depends on its. This is according to law of mass action. So change in concentration, that's over change in time, that was called as a law of active masses. So the rate of this reaction depends on the active masses of the reactants. Then last question for today. If doubling the concentration of the reactant A increases the rate 4 times and tripling the concentration of A increases the rate by 9 times, the rate of the reaction is proportional to. What do you say about the answer? Rate is equal to K into A. There is only one reactant they have mentioned. If you double the concentration, that's you make 2A. Say we don't know what is the power X, but the rate increases by 4 times. If you triple the concentration of A, so you don't know what the power is, both the powers will be same, and the rate increases by 9 times. So 2 to the power X is equal to 4. 3 power X is equal to 9. What is this X then? 2 power X and 3 power X, that would be X is equal to 2. 2 power 2 is equal to 4. So the square of the concentration. So it is the option B, which is the right answer. Thank you for watching. Keep supporting, guys. We are always going to deliver better content along with your help and your like and your subscriptions. Keep watching.